Hi students, today we are going to start with a new topic or chapter, that is chapter 14 from your syllabus, that is 12 nature of radiation and matter. Here 12 means 2 nature of radiation and matter. Just like some waves or radiations are acting as a wave or particle or matter sometime. This you will understand while after studying this lesson what is meant by dual nature of radiation and matter. Here you can think or you can consider only that dual means two nature of radiation and matter. Okay, so you have studied in your 11th standard about electromagnetic radiation, or you can say electromagnetic spectrum. So you are knowing that light is electromagnetic radiation, and the most of the phenomenon just like reflection, refraction, interference, diffraction and polarization of light is explained on the basis of light as wave, or you can we have considered light as a wave. You have studied all these phenomenon: reflection, refraction, interference, diffraction. This you have studied in 12th, right, along with polarization also. So when we have studied any point or any definition or any concept in interference, diffraction, magnet, and or you can say polarization or reflection, what here I have said always, a light wave or wave of light is incident on. Okay, so we have considered their light as a wave, and then only we can explain these phenomenon, that is these phenomenon, that is reflection, refraction, interference, diffraction, polarization, we can explain on the basis of light as a wave. Now you are knowing that light is an electromagnetic radiation consists of mutually perpendicular oscillating electric and magnetic fields. Both are perpendicular to the direction in which wave and energy are traveling. This I have studied in 11th also. That is what is the nature of light. Nature of light is what? Electromagnetic. Light is electromagnetic radiation, and how it propagates in the medium, it have two components, which are those electric and magnetic component, that is you can say electric and magnetic fields, and both are oscillating perpendicular to each other, and direction of propagation is always perpendicular to the both electric and magnetic field. Okay, now you have studied again black body radiation in the lesson kinetic theory of gases. But this black body radiation we cannot explain on the basis or by considering light as a wave. Then this phenomena appearing during the interaction of radiation with matter and need quantum physics to explain them. Okay, matlab black body radiation cannot be explained by considering light as a wave. Okay, and so this phenomenon happens. So if this phenomenon happens, there is a need of quantum physics, or you can say modern physics, to explain this black body radiation. Then what is meant by quantization of energy? In black body radiation, or black body radiation happens when interaction of radiation with matter takes place, and this cannot be explained on the basis or by considering light as a wave. So there is a new proposed idea of quantization of energy, which is explained or proposed by Planck. And what he proposed, that the quantization of energy means energy emitted in packets and at higher frequencies. What it means? Planck assumed that atom behaves like tiny oscillator that emit electromagnetic radiation in discrete packets. Discrete matlab it will have some particular value, which is E, that is energy of that packet is equal to n h nu. यहाँ पे n क्या है? n is the number of packets, h is the Planck's constant, and nu is the frequency. So any atom which is working as an oscillator emits some energy with the surrounding, and that energy is emitted in terms of packets. ओके जैसे आप कोई भी एग्जाम्पल ले लो पेंसिल या पेन का, पेन एक होता है, वन हाफ नहीं. ओके सो वन इज द पैकेट ऑफ द पेन. सो इफ यू आर हैविंग 10 पेन्स टुगेदर, तो उसमें जो सिंगल पेन है उसकी वैल्यू, दैट इज डिस्क्रीट वैल्यू, इज 1. ओके जस्ट लाइक दैट any atom which behaves like a oscillator emits some electromagnetic wave, or you can say radiation, in the form of discrete packets. Okay, तो energy जो emit होगी that is not continuous, it's just like a packet, and that value of energy of packet is E is equal to h n h nu, and the emission occur only when oscillator makes a jump from one quantized level of energy to the another of lower energy. Okay, so ये कब possible होगा? emission atom already excited state में है, when वो एक्साइटेड स्टेट से अपनी ओरिजिनल स्टेट में वापस आना चाहता है, एंड इट विल लूज इट्स एनर्जी विद द सराउंडिंग, और इट विल लूज इट्स एनर्जी एंड कम बैक टू इट्स, यू कैन से, intermediate equilibrium state. So when atom is at higher energy level, it will lose its energy and come down to its original energy, or you can say equilibrium. So this only happens when atoms at higher energy come back to its lower energy, that is emission of electromagnetic radiation. Okay, this is all about introduction, that why we are studying dual nature of radiation and matter. It is because you have studied some phenomenon just like reflection, refraction, interference, diffraction, polarization. These phenomenon can be explained by considering light as a wave, but black body radiation cannot be explained. The phenomenon which is black body radiation cannot be explained on the basis of, or by considering light as a wave. So if this cannot be explained, then due to this we can consider that electromagnetic radiation can have dual nature. Sometimes radiation sometimes matter. This you will understand while we are going forward in your topic. Okay, now we will study the photoelectric effect. Then what is it means, or what is the photoelectric effect? This we will study now. That is, Heinrich Hertz discovered photoelectric emission in 1897 when ultraviolet light is incident on metal electrode. A high voltage spark passes across the electrodes. Electrons were emitted from metal surface. That is, you can see this in the figure, that this is one metal surface which consists of electrons. You are knowing that any atom is having, or any metal consists of electrons, while we are when ultraviolet light, that is UV radiations, are is incident on metal surface, what will happen? After, electron will eject out or comes out from the metal surface, and this is called as photoelectric effect actually. That is, here photosensitive surface means what? Which emits electron when illuminated with appropriate radiation. ओके, तो ये जो मेटल प्लेट है दैट इज फोटो सेंसिटिव, मतलब व्हेन आप लाइट या यूवी रेडिएशन इस पर इंसिडेंट करोगे देन इट विल emit electrons. So this material is sensitive to photo, or you can say light. Okay, then what is photoelectric effect? Phenomenon of emission of electrons from a metal surface when radiation of appropriate frequency is incident on it. Okay, that is, emission of electrons means metal surface will emit or eject electrons due to radiation of appropriate frequency is incident on it. So यहाँ पे हर्ट्स ने कौन से रेडिएशन इंसिडेंट किए थे? यूवी रेडिएशन. दिस is incident, that is UV radiation is incident on metal surface, then this metal surface is photosensitive, and due to that it will emit electrons from the surface, and this is what? Photoelectric effect. Metals like zinc, cadmium, magnesium, etc. ultraviolet radiation is necessary. Means this metals just like zinc, cadmium, magnesium will emit electrons when ultraviolet radiations are incident on it. For alkali metals visible light is sufficient. Means आप कोई भी बल्ब या लाइट लोगे visible light, then alkali metals emit electrons. Okay, now we will study experimental setup of photoelectric effect. You can see diagram on your screen in which you can see here one quartz window, that is photosensitive emitter plate, collector plate, then external circuit you can see. Here this evacuated glass tube with quartz window. तो हमने क्या किया है? एक we have took one glass tube with quartz window to emit or to incident, sorry, not emit, to incident light on, or you can say electromagnetic radiation on metal. Here E is what? Photosensitive metal plate. Matlab, if light is incident on this plate E, it will emit electrons, or you can say E को आप क्या बोलोगे? Emitter. और यहाँ पे एक्सटर्नल सोर्स का निगेटिव सप्लाई हमने क्या किया है? ई को प्रोवाइड किया है. सो ई क्या है? कैथोड है. सी क्या है? अनदर मेटल प्लेट, एंड विच आप सी को क्या बोलोगे? कलेक्टर. इट इज़ बिकॉज जो भी इलेक्ट्रॉन्स ई से इमिट होंगे वो सी में क्या हो जाएंगे? सी में हम उन इलेक्ट्रॉन्स को कलेक्ट करेंगे, and hence C is having positive charge, and that is why we can call it as a anode. Okay, now emitter and collector are connected to a voltage source ammeter to measure the current. वोल्टेज सोर्स को से हमने क्या किया? E और C को कनेक्ट किया. E is having negative charge, C is having positive charge, and we have connected one ammeter to measure the current which will flow in the circuit. Okay, this capital V is potential difference measured by voltmeter, which is maintained between the emitter and collector. Here E is negatively charged, that is emitter, and C, that is collector, is positively charged, and due to this there is some potential difference between them, and this is measured by using voltmeter. Okay, potential difference can be varied, and C can be negative potential with respect to E. Then we can vary the potential difference between emitter and collector, and sometimes we can make collector as a negative potential or negative, okay, negative potential with respect to E. E भी negative हो सकता है और हम C को भी negative बना सकते हैं. Okay, when anode, that is C, potential is positive, it accelerates electron, called accelerating potential, and potential is negative, it retards the flow of electron, called as retarding potential. When collector, जब हमने डिफाइन किया कलेक्टर क्या है? एनोड है. व्हेन इट इज कलेक्टर इज हैविंग पॉजिटिव पोटेंशियल, जो भी इलेक्ट्रॉन, ऑल द इलेक्ट्रॉन्स विच आर इमिटेड फ्रॉम ई इज कलेक्टेड बाय कलेक्टर सी. ओके, सो इलेक्ट्रॉन्स जो भी इमिट होंगे दैट विल गेट अट्रैक्ट towards the collector due to its positive potential or positive charge on that collector C, and due to this positive potential or positive charge on C will act as a accelerator, and that is why positive potential on C is called as एक्सेलरेटिंग पोटेंशियल. और जब C का पोटेंशियल निगेटिव होगा या फिर C निगेटिव टर्मिनल होगा, देन इलेक्ट्रॉन एंड C अगर निगेटिव है, बोथ आर हैविंग रिपल्सिव फोर्स, और वो क्या होंगे? इलेक्ट्रॉन क्या होंगे? विल नॉट गेट अट्रैक्ट टूवर्ड्स C. तो आप उसको क्या बोलोगे? रिटार्डिंग पोटेंशियल. हियर S जो आपको दिख रहा है डायग्राम में, एस इज व्हाट? मोनोक्रोमैटिक सोर्स ऑफ लाइट ऑफ सफिशिएंटली हाई फ्रीक्वेंसी. ओके, मेटल प्लेट ई इजेक्ट इलेक्ट्रॉन. इजेक्ट मतलब इमिट. Metal plate E emit electron when light is made to fall on it. ये source S, when we switch on that source S, तो क्या होगा? There will be source 1, when we switch on the source S, light, which is light will incident on plate E. प्लेट E क्या है? फोटोसेंसिटिव मेटल प्लेट. सो फोटोइलेक्ट्रिक इफेक्ट क्या है? व्हेन अ light or electromagnetic radiation of appropriate frequency is incident on photosensitive material or metal, then it will emit or eject electrons. So this will happen that when sources get switched on, or when source is switched on, light is incident on metal plate E, which is photosensitive, and due to this electrons will eject or emit from plate E. These electrons are called as photoelectrons. जो भी इलेक्ट्रॉन प्लेट ई एमिट करेगा आप उसे क्या बोलोगे? फोटोइलेक्ट्रॉन्स. ओके. नाउ photoelectrons are collected by collector C. C का नेम क्या है? collector. So it will collect all the electrons which are emitted from plate E. So have you understand what is photoelectric effect? Photoelectric effect is what? Phenomenon of emission of electrons from metal surface when radiation of appropriate frequency is incident on it. Okay, so you can see in the diagram on the metal plate UV radiation is incident, and due to that from that metal plate electrons are emitted, or emission of electrons takes place. So this phenomenon we have studied experimentally. So experiment कैसे होगा? That is, there is a one evacuated glass tube with quartz window. Window किसके लिए है? To incident light on plate E. E is the emitter, that is metal plate, photosensitive metal plate, and A is emitter and cathode. External source का negative terminal we have provided to metal plate E. Then C is what? Another metal plate which collects all the electron which are coming from metal plate E, and it is anode because we have provided positive terminal of external supply to the plate C. Emitter and collector are connected to the voltage source and ammeter. ओके, तो आपने एक्सटर्नल सप्लाई दिया, उसको आपने क्या बोला? वोल्टेज सोर्स, एंड वी हैव कनेक्टेड it to the ammeter to measure the current. Okay, then V is what? Potential difference between the emitter and collector. Now we can vary, मतलब हम क्या कर सकते हैं? We can change the potential difference between collector and emitter. So we can change collector from positive potential to the negative potential. When C is positive potential, or you can say anode, it accelerates electrons which are emitted from metal plate E. Hence the potential on plate C is called as accelerating potential. And when, if we change collector plate C from positive potential to negative potential, then what will happen? Electron emitted from E will not reach to C. It is because both are having negative charge, and this negative potential on collector plate C is called retarding potential. Okay, then S is the monochromatic source of light of sufficiently high frequency. Okay, then when the source is on, light is incident on metal plate E. After that, E will emit or eject electrons, and that electrons are collected by metal plate C, or you can say collector. The electrons which are emitted from plate E is called as photoelectrons. It is because photo means light. Okay, so the electrons emitted when light is incident, or you can say light is incident on metal plate. So these electrons which are emitted or ejected from plate E due to light is called as photoelectrons. So these are all about introduction and photoelectric effect. In next lecture we will see observation of photoelectric effect. Thank you.